Alright guys, so we're gonna look at reviewing our test today. A lot of us didn't do so good, or we didn't meet our goal that we were wanting for our star scores. But some of you did really well, so kudos to you, but everybody's gonna go ahead and correct their test today. So let's start with number 1. It says, which of these landforms would most likely be found at a divergent boundary? So if you remember, a divergent boundary is where plates are moving apart. So where plates are moving apart, you see the lava. Let's see if I can get a pin over here. Here's a plate. Here's a plate. And what you see is the magma coming up in between them. Okay, so what that essentially builds are mountains. And whenever you get a chain of mountains, we call that a mid-ocean ridge. So these two plates that are dividing are two oceanic plates. They're dense. So the correct answer would be mid-oceanic ridge. Okay, number 2. In an area known as the Ring of Fire, volcanic island chains have formed in the Pacific Ocean. What most likely caused this to happen? So if you'll remember the Ring of Fire, it's surrounding the Pacific Plate. So remember, the Atlantic Ocean is expanding, the Pacific Ocean is getting smaller, and that's because the North American Plate, the South American Plate, the Eurasian Plate, the Australian Plate, they're all sliding on top of the Pacific Ocean Plate, making it smaller. So the Pacific Ocean Plate is going under, and the continental plates are going over, which makes a subduction type boundary, which is also known as a convergent boundary. So they're converging, they're colliding. Number 3. Scientists believe that convection currents within the blank are responsible for the movement of the plates that form the Earth's crust. So if you'll remember, the lithosphere is actually where the plates are. So that's the portion of the Earth's layers where the plates live. The inner core and the outer core have nothing to do with convection currents. So convection currents are in the asthenosphere, that's below the lithosphere. Number 4. The most recently formed crust of the Earth would be found where plates move sideways, where one plate is going under another plate, so that's actually melting right there. So we're not going to have new crust, we're going to be recycling old crust. Where two plates are pushing directly toward each other, okay, well that makes mountains, we're not really making new crust. And then where two plates are moving away from each other in opposite directions. So this is the correct answer, because like over here at number 1, you're actually seeing that magma pushing up between the plates, and then you have seafloor spreading that's occurring. And so all this ridge right here, that's all new seafloor, that's all new crust. Okay, let's look at number 5 real quick. Using the piece of topographic map below, in which direction would you expect a delta to be formed? Okay, so I defined delta on the whiteboard for you. So a delta happens whenever you have a river that's flowing and it deposits all the sediment at the end of the river. We call that the mouth of the river. So for example, we have lots of rivers in Texas that empty out into the Gulf of Mexico. These rivers are fast traveling, but whenever they meet the Gulf of Mexico, they're entering a body of water that is a lot slower. And so what we see is this release of sediment from the mouth of the river that it's been carrying from all over Texas. So this delta is a fan shape because all the sediment just releases out of the river, and it looks something like that. So remember our V's in our topographic map. Okay, think about Pac-Man. So whenever Pac-Man eats too much, he throws up. So the direction that we're throwing up is the direction that the river is flowing. So if the delta forms at the end of the river, okay, in this scenario, it's going to actually form to the left, because over here is the left, and this is the right. Let's see if I can spell it out here. There you go. Alright, number 6. If the river in the topographic map illustrated in the previous question cut a deeper canyon over time, what would the topographic map of the area look like? So we're looking for previous question number 5, and if it cut a deeper canyon. So how do we know something is deeper or steeper? Well, the lines have to be closer together, and we know that our river ran to the left. So I want to check and make sure which way all of these pictures are running. So F and G, the rivers are both running towards the left. In H and J, my rivers are both running towards the right. So my only possible answers are F and G. Now if I want a deeper canyon, the only answer possible is G because the lines are closer together.